Hey all, welcome to my Specs and Tech, Tech and Specs, whatever I'm going to call it, overview for my Flinger 5000. This thing is turning out to be a really cool project. I'm loving it, but it's getting a little expensive. So, so I just want to show you what's all involved in here. So these are all three of these are the high-tech servos that are running it. And this is a electric motor from also an RC truck, Traxxas model. Got microcontrollers, motor controllers, FTTI chips, and then a whole bunch of plastic and some metal parts. So I'm going to go over all of that, as well as a new power supply. And, you know, let's have a look at how some of this stuff has actually been assembled. And I can't wait till I finish this project, because then I get to clean up my hobby room. If I clean it up now, I'll never find anything that I need to finish it. But I'm getting there. It's going to take a little bit longer, but whatever. So this is a new servo that I just put in. I'm replacing the original servo. This is right here. This is what was in there. This is just a standard Futaba S3003, 4, whatever. It's got about 20 inches of torque at 4.8 volts. I'm running everything at 5 volts. This is 20 inches of torque. It wasn't quite enough. You can see up here, I've got this black band on here, and up here, and I'll talk more about that in a minute. But that's why this servo wasn't really enough. So that's the latest servo to go into it, and that's also the high-tech servo, and it's this one right here. If we look at the specs of it, it is called, hang on, I'm dropping stuff. This servo is called the HS6635 digital torque. If we look at the specs on it though, I don't know if you can focus on that. So this is 0.18 seconds for 60 degrees at 4.8 volts and 69 inches of torque. So it's quite a bit stronger, but not bad. Now remember those specs. We're going to talk about that in a bit. This here is a mini servo running the tilt, because the tilt, this is actually very well balanced. I got a little bit lucky on the pivot point, and it came out very well balanced. So it's really cool that this servo doesn't really need to be very strong, but it is fairly quick. Plus there's the leverage of the angles, which worked out well. So this servo is a high-tech HS B2MG. This is a metal gear servo. That's another thing about this servo that's down here. This is a carbonite gear. Yeah, it's not even metal gear, it's carbonite gears. It's overkill. The micro servo for the triggers, or for the tilt I mean, at 4.8 volts is 0.12 seconds, so it's a lot quicker, and it's got almost about 38 ounces of torque, inches of torque, which is more than sufficient to tilt this thing up and down. The trigger servo though, this is where things get interesting. The trigger servo runs on actually 3 gears and a rack. The bottom of the trigger, or the firing pin, is a rack, and this is actually a 4-to-1 ratio that goes all the way down. So this high-tech servo is actually a really strong servo. It is the HS645 Metal Gear Ultra Torque servo. Look at this thing. At 4.8 volts, it has 107 inches of torque. It's almost double this carbonite gear. I'm really tempted to just pull out the carbonite gears, stick them in the giant ass Ultra Torques, and why? See, these servos were about the same price. I think this one was actually a little bit less. I could be wrong, but they were right about the same price. This is definitely the more powerful servo, but this one is definitely the stronger servo. Now, if you take the strength out of this and put it into there, I mean, you got something that's going to do everything you ever needed. So those are the servos. All the wiring for everything, even the motor. This is the Titan 380 motor. It's out of a Traxxas, actually I think it's out of a Traxxas 8th scale, no, not 8th scale, what is that, not core scale, the other way, 10th scale truck. It's actually not near as powerful or whatnot as I was hoping and whatnot, but it worked out well. At full speed it does shoot a dart very well. You saw it in an earlier video. That wasn't quite full speed. See, the thing is I had the throttle limited to 90%, but also I topped out 100% to only be about, 200 PWM instead of 255. So I do have higher throttle to go on that. When you look in here, these are all 3mm by Well, I think they're actually 1/8 inch by 1/2 inch screws, little cap head screws, but they look awesome. That's why I really like them. They're round, they stick up, they have a really good look to them. I've used 3mm steel shafts everywhere. You see here, there's a 3mm steel shaft, there's the inside there. All of those steel shafts are on using 3mm wheel collars as well. And they all have that set screw in the side. But if you look, you can't really see where the set screw is, especially when they're embedded like that. Isn't that cool? I managed to get the prints really well, and really nice fits for all of these, so that everything fits and it has a really nice finish and flush, and that's the important thing. If we all look down here though, we'll see a hole in all the side, and if we look on the arm here, I think the hole is, where's the hole? I don't know. Oh, there's no hole in the middle because there's no piece there, but if we look here, there's a hole around there somewhere. I know we're out of focus. There's the hole. So that's where you can actually get the set screw in. So the way to put them in is you actually take the set screw out, push the collar into the hole, making sure that the hole in the set screw points to the hole in the plastic. Once it's pushed in, then you can just put your set screw back in and screw it in, and it stays there because the set screw fits just barely in the hole, holds it all together nice and beautifully. And you can see I've used that same system everywhere, and it works very well. It's a very good system. So down here at the bottom of the pan servo, the servo actually fits right into a ring like this. This is for the Futaba servo. The high-tech servo has a slightly smaller diameter output shaft, so I'm going to print a new one of these with a slightly smaller center hole, and you can see how there's it only goes in so far, and it's the same with those. The reason is, so once this actually goes on last, this piece actually gets screwed into the bottom of the base. You can see there's a recess in there, and the hole through the bottom. So I did this intentionally, thinking that I might have to replace this servo or use a bigger servo. And the last thing I wanted to do was have to reprint this entire base just to put a new servo. So that's why we used the plates. So the plate just screws right into there. You got the 4 holes. So the plate screws in. In this case, I get a new plate, so I took the old plate out. I'll screw the new plate in. And then once I make sure I have the servo lined up correctly, I can just drop the tower, push it into the hole, and then, oops, it just fell out. And then I can just put a screwdriver through the back end with the screw, and that screws the servo into the face plate, into the torque plate, and it holds it all together, and it works like a charm. Some more electronics. Here's what we have. This is called the Arduini. This is a Solar Robotics product. It's called the Arduini. It is in fact an Arduino with the footprint of the Atmega 328 itself. It's called a backpack. It's very simple. Doesn't have a lot of the features, like there's no USB. That's what the pins sticking up there are for. But it does have the oscillator. It goes right here. You have your pin 9 LED or pin 13 LED or whatever, which one it is, I never pay attention. A couple of capacitors and your resistors, and basically, boom, you're done. You have an Arduino with the footprint of the Atmega chip itself. And that's where you end up using this, is the FTDI to USB, which just plugs right onto the top here. So this is the one I've been using. Now I've only got the one, but I have several of these, plus a couple of other Arduino Pros. So I need to actually mount that into the electronics package, and I've been having a hard time trying to figure out how to mount that in there. So when I was up at the electronics store today, I knew I had to pick up another one of these anyways, but it turns out these are discontinued because SparkFun decided to make them smaller. So this is the exact same thing, but much smaller. I mean, look at this. There we go. Sorry about the focus. I gotta get a better camera, and I will soon. Actually, that is on the agenda now. So this one actually turns out it's going to be a little bit easier for me to mount than that one, believe it or not. See, the idea is I'm just going to sit this into a little bit of a depression, and I just need a little bit of edges to catch it so that it doesn't slide in and out when you. But anyways, that's what's coming up. So that one's going to work out very well. And this down here is another Solar Robotics product. This is the compact motor driver kit. This is capable of running 2 DC motors using PWM outputs from a microcontroller to control both the motor speed and direction and braking capabilities. I've used this on small projects using the small little RM motors, the tiny little ones, and I've never taxed one of these, but this new project running all of this is really cool. So I'm going to be running 2 fans inside the case as well. This fan is specifically needed to cool the LM298, I think is what it's called, motor controller chip itself, because that thing gets hot. It really does. There's a lot of electricity flowing through here to drive those motor, and yeah, it gets hot. There's also driving another fan. This is a Noctua 40 millimeter fan, which will actually just be in as a cooling fan in the entire case itself. But this fan will be directed, it'll be sitting on the edge of the case, and will be directed immediately onto, you know what I mean, sorry about the darkness. Just to cool that. It needs it. Without it, this goes into thermal shutdown rather easily. So yeah, that's why I put the heatsink on there too, because it really does need it. The cables are just your standard 3 pins, and they actually go straight to the microcontroller, so that you can control the enable, the direction, and the speed through PWM, and that's very cool. This one, which runs these fans, is actually just doing a loop back. So what's really cool about this, another thing that's really cool about the compact motor driver, is you put your raw voltage in here on the outside. This is power in, this is ground. There's also a 5-volt power regulator built into this with a 5-volt output. So you can just bring whatever your raw voltage is in to power your motors, and then you also have a 5-volt out to power either your microcontroller and whatever else you got going on. And that's how this setup works, actually. So my 12-volt voltage from the power supply comes into here. The 5-volt comes out to power the servos. The 12 volts main is powering the big motor for the spinners. And then the microcontroller itself is actually being powered through the USB. That's right. That is right. And yet it's still absolutely able to control everything just simply by crossing the ground from... So this has a ground on it that you're actually outputting. And then you connect it to the ground there. And you're done. It all will talk to each other very well, actually. So this is the CPU that or the power supply that I'm not going to use. I've actually just been using, this is just the one that I use around the house now for working on. It's got a switch on there for turning it on and off. But you'll notice I've been building this, I decided to build a little stand for it. I'm going to elaborate a little bit on this. So yeah, I got a nice little CPU stand, or power, so I keep calling it a CPU, a PSU, power supply stand. Worked out very well. But why did I say this is the one I'm not going to use? Because I hate that. You see that giant bundle of wires? I hate that. The only thing I'm using out of this entire power supply is this. This is the ATX over here that's been hacked up, and I'm going to keep those. And the rest of this is just this big mass of wires. So I'm actually going to go pick up a Corsair 450 watt modular power supply. So there's just a bunch of plugs back here. This mass of wires are just, they have plugs on this end. So, and there's other plugs that are in the back of the power supply. So whatever cable you need, you plug in. And because I don't need any, I won't have any cables. I'll just have the main ATX that is already braided even. I don't even have to braid them. But I do have to yank out the power and grounds, which are the green and black, which is a pain in the ass. And then pull out a couple of 12-volt lines. So, and then that'll be it. It'll look really much nicer. Plus the new case I'm making will actually have a nice little fiberglass handle from a tube that's in over there, as well as these little arms that come off for rolling it around, because the power line that I'm actually going to use will actually be quite long. This is it right here. So this is actually what's going to be going from the power supply, and then it'll actually, I'm going to put a different plug on there, a locking plug. So it's actually, you know, it's a good 6-7 feet long actually. So that way I have good reach and I don't need to have the power supply close to anything. This is the USB cable. So this is all going to be braided. I have additional, somewhere in there, you can see the rolls there, cable braiding. This is cable braiding I did. So this power line is going to be braided. All of that will be braided, or sleeved. I mean, sleeved with braided sleeving. But it's also going to have the micro USB cable inside that sleeving as well to make it just one piece, which would be really nice. This is a very long micro USB cable, so it'll actually pop out of the sleeving about 3/4 of the way down, and you know, it'll look really good. And then all of this will be inside there. There'll be a couple of plugs on the side for power, for USB. The only thing I can't really deal with is the USB camera. It has its own USB cable, and it's kind of a limiting feature. This is a really cool thing. This is a PCB vise. You can find it on Thingiverse. That's actually what's printing there. So you can see the what it's printing there will actually end up being glued to here. On the back of that, you can see the threaded bits. So there's a screw, which he screws in there, and that cup just sits on here. So you end up with a really nice PCB vise with really great jaws. If we look at these jaws, you can see how they have actually nice angled grooves in them, so holding your PCB in any which way. And it's on a screw with reverse threads on each left and right. So, and these grooves are really nicely shaped, and they're really deep, so you don't actually have to unscrew this very far, and then you can just slide your PCB in and out. It's really cool. You don't have to hold it. Once you figure out where your distance is, you're done. It's really a great little piece of engineering that somebody put up on Thingiverse. PCB vise, printed circuit board vise. Check it out if that's something you're interested in. Okay, I think that covers everything else. Oh, where is that? Okay, okay. So I missed a little bit centering this. This isn't quite centered perfectly this direction inside this tower. That means that the whole tower is slightly off kilter. When I just realized if I measure accurately enough, I could find out exactly where it's off kilter, and then I could just move this damn hole. It's not going to help me, actually. But anyway, so this band takes up the additional space. If I pull out, I've custom cut out of those 3mm shafts I was telling you about and showing you. Custom cut little short axles which fit into there. You can see the axle. And then I have a little wheel which fits on there. And you can see it's a really nice fit, right? In a way, it gives it a nice look from the outside. It just sort of disappears into there. So the wheels press against this black rubber band. This is actually Ninja Flex. It's a printed filament that I made, and it presses against the wheels. And then inside here, this is the tower collar. This is the bottom. So you can see there's a hell of a lot of holes, but on top, it doesn't have as many holes. So right here, there's no hole. But on the bottom there is. So that hole doesn't go all the way through, is actually used to go onto the axles and hold the axles in place. And then all the other holes just line up with the screw holes. I really like this look. It came out very well. Again, using those same screws, but when they go in flat, it just looks so cool. All you see is the silver heads flush, and it does look brilliant. I really like the way all the silver really highlights against the 3D printed colors. Sorry if I'm not being accurate with my camera. I'm really trying to do a good job here, but I suck. The firing barrel, this one here, that didn't help, did it? So the free axle barrel, this is actually really interesting. So that's running on a 3mm shaft. It's held all together. There's actually 3 wheel collars all together. There's one embedded in the bottom. There's another one. I have many examples here. This is what the front of that plate looks like. And you can see where that notch is. So that notch just allows me to put a tightened wheel collar in there. You'll notice that that screw hole, or that little notch, whoops, well, it would line up perfectly with the little grub screw, so it allows me to put this in flush. Hey, that's finished. Okay, so then there's a little, I actually printed some spacers. If you're looking there, you can see these white little rings. Those are 3D printed washer spacers. So there's a spacer, and then the barrel slides onto the axle, and then there's another wheel collar on top. Now, I sort of skipped over something. Inside the barrel, and you can't actually see them, are ball bearings. There's actually one ball bearing right there at the top, and there's a second ball bearing right there at the bottom. Yeah, I don't have any others to show you, but that's why this runs so smoothly, is that's actually on dual ball bearings. I can't just take it apart because it's a pain in the ass, and I've got my screws there. And so you just have to take my word for it, I'm sorry. What else we got? So you can see how those screws look. So this is, again, modular. You can see the design that I built. This is something that was intentional from the very beginning, was to make sure that I could change out the motor mount if I ever needed to. This is the motor that I fried when I first tried the power supply, and I know this motor's fried. It doesn't work at all anymore. I've tried various configurations. All my other test motors work fine, but this one just doesn't work anymore. I went back to Active Electronics and did a little bit of hunting and comparing, and I actually found out what this is and why it blew up. So I'm just going to throw that away. Bye-bye. It is, in fact, where'd it go? This motor. It's just, I was is that it? Oh, that is it. So this is the motor. It's a 6-volt motor. But look at the RPM on it. 11,400 RPM. That motor went screaming at 12 volts. Like, I got scared. I went running out of here. Now I know why, because that is a frightening motor at 12 volts. So I'm going to rejigger some stuff here, and I'm going to run it at 5 volts, because I can't do 6 volts. 6 volts is an odd number for me. I don't know what I'm doing with shit like that. So I have a 5-volt power regulator there that I'm already just going to hook up. Actually, better yet, I can do this a different way. Anyways, and I'm going to run, I have it's already mounted here, and I'm going to give that a test and see what happens at 5 volts, because I think that's going to be a damn good motor. It's going to hit like 10,000 RPM at 5 volts, and I know that's faster than this. I also picked up this motor. This is a 12-volt motor, 8,700 RPM. This is actually a bigger motor than this other 12-volt motor I have. This motor wasn't entirely impressive. I ran it at 12 volts, the same setup I'm running that at, and it was really about the same. And you know, all I gotta say is I'm really kicking myself in the ass, because that motor there was something like, it was over 40 bucks. This thing was 6. The 6-volt is less than 6. That thing was over 40 bucks. I don't want to, I'm very pissed off about buying that motor when these ones are so much better for my use. So, as I was saying, with the motor mount I designed, they're interchangeable. There's just the 4 screws, 2 on the side and 2 on the bottom that hold it in. But the way this has been shaped and designed is that it's a very snug, very tight 3D fit in there, and it fits very well. There's no slop. There's no deformity, there's no pressure, there's no nothing. It's just a really perfect fit. And with the 4 screws, it just holds it all together. There's no pressure on the angles. As you can see, it's been the one in the bottom and then there. And that's where these things come in. They're additional strength bars that have been printed on top to give it additional strength. This bar is to give it strength between the firing barrel and the motor to keep it from warping side to side. Okay, I think that really does wrap it up. So it's going to take me probably I'd say another week and a half to 2 weeks to finish it off. The difficulty now for me is designing the electronics box. I'm just using perf boards and wires and whatnot. So I'm just designing the actual circuit board that or the Arduino will live on and all of that. And then this board, and that small little FTDI breakout board all have to go into an electronics box with room for the fans. And because I had to get this printed and working, there that goes again, long before I got to that point, the point that I'm at, I thought I was going to properly predict or, do something, but I failed. So, the way I made the washer plate for this so that I can change servos easily enough and the mount there, I try and plan ahead. This time I don't think I got the right idea. So I've got 3 holes, and I already have the plate that's properly shaped to go over the round to screw on there to form the base of the mounting for the box. But if I could do it over now, I would actually change that hole pattern and do something a little bit different, because it's actually given me a bit of a challenge now to try and properly build a box to hold these components. See, I don't want to just put a big box. I'm not going to just have a big plate sticking out here with the 3 things sticking on it, because that's just too big. What the hell am I pointing my camera at there? I don't want a big plate just sticking out here. Instead, I'm going to have the main board here is where all the servos will plug into. So that's actually going to kind of stand up like this towards the back with those headers pointing straight up. So the servos can just nicely plug right under the top. The motor controller will be mounted on the bottom with the fan. So there's actually a bit of work and planning that I have to do to try and figure out not only how to design it, but how to design it in a way that it can be printed and then assembled. So that's the tough part. So my fan just turned off. That means it just hit 50 degrees. Yes, it did. So this is my E3D head. Let's take a look at what's been happening with the E3D. Total time printing, 12 days, 5 hours on my new E3D V6 head. Yeah, I've kind of shocked my motherboard twice now, and the panel just doesn't work anymore. It's a new motherboard too. Alright, so that wraps it up for my Flinger Techs and Specs update. Can't wait till I finish this project and I can just finally clean this table up. That's not beer. That's cheap ass